To understand antimatter, we first need to talk a bit about matter. You and I and everything we deal with in normal life is what we call matter. And matter is made of molecules and atoms and particles. This guy, for example, is also made of matter. His name is Jeffrey Hangst, and he is one of the world's most renowned researchers on antimatter.
You and I are basically three things. We have neutrons and protons in our nuclei of our atoms, and we have electrons circling. Three particles. For each type of particle that we've identified, there's the possibility of having an equal but opposite particle we call antimatter. Now, how are they anti? Particles of matter and antimatter have the same mass, but opposite charge. Electron has a negative charge. Positron, which is the anti-electron, has a positive charge.
So antimatter has the exact same structure as matter, but in reverse. In 1928, an English physicist named Paul Dirac predicted the existence of antimatter on a theoretical level.
The dude doubled the universe. We only had half of it until he came up with this amazing theory that predicted that there was something else.
According to the laws of physics we know today, you could actually build yourself a universe out of antimatter. It behaves in the same way. It just can't come into contact with the stuff we call matter.
If you put them together, they annihilate. They release energy in the most violent way that we know about. So this is where the science fiction takes off in, antimatter, doomsday weapons. That's all true. I mean, that could all be done if you had yourself some antimatter. Problem is, doesn't seem to be any left in our universe. So you have to make it if you want to study it. And that's what I do. That's my day job.
One of the most motivational reasons for Jeffrey and his team to study antimatter is the elephant in the room question. What happened to the antimatter that should have been made at the time of the Big Bang?
Our theory tells us that there should have been equal amounts of matter and antimatter at the Big Bang. And we only have matter left as far as we can tell. Right, we're going looking for this all over the universe to see if there's some place where there's some matter and antimatter that are annihilating. There's like a boundary or something. But so far there's no evidence that there's any antimatter left. And we have no idea why. So the way I like to think of this is, if you can get your hands on some antimatter, and that's what I do, we grab it, we make it, hold on to it, and study it. I think you're kind of morally obligated to try that. If you can do it, you should look really carefully to see if there's something we've just missed.
So in theory, if you observed two human beings standing next to each other, one consisting of matter and the other of antimatter, you wouldn't be able to tell the difference. But if the two human beings touched each other, they would explode in a burst of energy, cease to exist, and new particles would be created. This is called annihilation.
It is nasty stuff. If you don't want to be around it if you had a macroscopic amount. But we just don't, and we never will. It would take longer than the age of the universe, and it would use more energy than we know about. Okay, it's a complete losing proposition. That's the fiction part. Everything else about it is real. It's a complete alternative to regular matter. And we have no idea why you and I are made of matter and not antimatter.
Stay curious.